All right, let's get into it. Number 12, the Silurian hypothesis. In April 2018, NASA climate scientist Gavin Schmidt and University of Rochester astrophysicist Adam Frank published a paper in the International Journal of Astrobiology that asked one of the most quietly disturbing questions in modern science. Not whether alien civilizations exist somewhere out there in the galaxy, whether one might have existed here, on Earth, long before us. The paper took its name from the reptilian Silurians of British science fiction, an ancient species that supposedly predated humanity on our own planet. But Schmidt and Frank were not writing fiction. They were identifying a genuine blind spot in our scientific methodology. We assume, without ever really testing the assumption, that we are the first technologically advanced species to have arisen on Earth. Schmidt and Frank asked what evidence we would actually expect to find if we were wrong. The answer was sobering. An industrial civilization that burned fossil fuels for a few thousand years and then collapsed would leave behind only a thin, chemically ambiguous layer in the geological record after tens of millions of years. Plastics might persist in trace form. Isotopic ratios of carbon and nitrogen might shift. Pollen distributions might show a brief anomaly, but the signature would be subtle enough that we might already be looking at it and calling it something else entirely. Consider the Paleocene-Eocene thermal maximum, a carbon isotope excursion that occurred approximately 56 million years ago. It represents a massive, rapid injection of carbon into Earth's atmosphere, and its exact cause remains a subject of genuine scientific debate. Schmidt and Frank noted that the chemical signature of this event is not inconsistent with industrial activity. Not proof, but not ruled out. The Silurian hypothesis does not claim a prior civilization existed. It simply demonstrates, with rigorous scientific logic, that we could not prove one didn't. How many chapters of Earth's own story have we already misread as natural history? Number 11. The Great Filter. In 1998, economist Robin Hanson of George Mason University published a paper with a title that sounds almost mundane until you understand its implications. The Great Filter. Are we almost past it? The question embedded in that title is one of the most consequential humanity has ever asked, because the two possible answers lead to completely opposite conclusions about our future. Hansen built his argument on a foundation laid at Los Alamos National Laboratory in 1950, when physicist Enrico Fermi sat down to lunch with colleagues and posed what seemed like a casual question. If intelligent life is common in the universe, and if even a fraction of civilizations develop interstellar travel, the galaxy should be teeming with evidence of their existence. Fermi looked around at the silence and asked, "Where is everyone?" Hansen's contribution was to formalize what that silence implies. Somewhere between the formation of stars and the rise of spacefaring civilizations, something stops almost everything. He called it the Great Filter. The filter is not a single event. It is any step in the development of complex life that proves nearly impossible to cross. It could lie behind us in the extraordinary improbability of the first self-replicating molecule, or in the emergence of eukaryotic cells approximately 1.8 billion years ago, a transition so difficult it may have happened only once in Earth's entire history. If the filter is behind us, we are the lucky survivors of an almost impossible journey, and the silence of the universe makes sense. But the filter might lie ahead. It could be nuclear weapons, artificial intelligence, engineered pandemics, or something we haven't yet invented. Hansen made a counterintuitive and deeply unsettling argument. The discovery of even simple microbial life on Mars would be catastrophic news for humanity, because it would mean life arises easily, which moves the Great Filter from our past to our future. The universe has been forming stars and planets for over 13 billion years. If the filter is behind us, we are extraordinarily rare and extraordinarily fortunate. If it lies ahead, we are not the exception. We are simply the next in line. Number 10. The Missing Type 3 Civilizations. In 1964, Soviet astrophysicist Nikolai Kardashev published a paper in Soviet Astronomy that attempted to categorize all possible civilizations in the universe by a single metric: energy consumption. A Type 1 civilization harnesses the full energy of its planet. A Type 2 harnesses its star. A Type 3 harnesses the entire energy output of a galaxy, approximately 4 times 10 to the power of 37 watts. Kardashev assumed that civilizations of this scale would be detectable across cosmological distances. 60 years later, we have found none. The physics of a Type 3 civilization make its detectability almost certain. Any species harvesting energy at galactic scales must contend with the laws of thermodynamics. Energy use produces waste heat, and waste heat radiates in the mid-infrared spectrum. A galaxy being consumed for its energy would glow with a distinctive infrared signature even if it appeared dark in visible light. This is not speculative. It is basic physics, and it means that a Type 3 civilization cannot hide simply by turning off its lights. Its existence would be written in heat. In 2015, Penn State astronomer Jason Wright led the Glimpsing Heat from Alien Technologies survey, analyzing infrared data from NASA's Wide Field Infrared Survey Explorer telescope across approximately 100,000 galaxies. The team was searching specifically for this waste heat signature. They found 50 galaxies with unusual mid-infrared excess, anomalies that warranted follow-up investigation. The results were published in the Astrophysical Journal supplement series, and then the follow-up studies went quiet. No confirmed detections, no announcements. 50 strange galaxies sitting in a database, unexplained. Humanity currently sits at approximately 0.73 on the Kardashev scale, not yet a full Type 1 civilization. The mathematics of development suggests that a species expanding at even modest rates could reach Type 3 status within a few million years, a blink in cosmic time. The galaxy has been forming stars for over 13 billion years. Either Type 3 civilizations do not exist, or they have mastered a way of operating that produces no detectable waste heat whatsoever. Both possibilities demand an explanation that physics has not yet provided. Number 9. The Dyson sphere candidates. In 2015, citizen scientists working through the Planet Hunters project were combing through data from NASA's Kepler Space Telescope when they flagged a star that broke every pattern in the database. The star, cataloged as KIC 846282 and located approximately 1,470 light-years from Earth in the constellation Cygnus, was dimming in ways that no known natural phenomenon could explain. Astronomer Tabitha Boyajian of Louisiana State University brought the anomaly to scientific attention, and the star was quickly nicknamed Tabby's Star in her honor. To understand why astronomers were alarmed, you need to understand what normal stellar dimming looks like. When a planet transits a star, it blocks a predictable fraction of light in a regular, repeating cycle. A planet the size of Jupiter causes a brightness dip of approximately 1%. Tabby's star was dimming by up to 22% in patterns that were irregular, asymmetric, and entirely unpredictable. No known natural body of sufficient size to cause that dimming had been detected in orbit around it. The irregularity was what truly unsettled researchers. Natural occluding objects, whether planets, dust clouds, or swarms of comets, produce characteristic light curves that match physical models. Tabby's star produced curves that matched nothing. Physicist Freeman Dyson had proposed in his landmark 1960 paper in Science that an advanced civilization might build a vast structure around its star to capture the star's total energy output. Suddenly, Dyson's 55-year-old thought experiment was being seriously discussed in peer-reviewed literature. Further investigation deepened the mystery. In 2016, Louisiana State University astronomer Bradley Schaefer analyzed over a century of archival photographic data and found that Tabby's star had dimmed by approximately 14% over the preceding 100 years, a long-term secular fading that no natural explanation has since fully accounted for. A 2018 follow-up study by Boyajian's team confirmed that the short-term dimming events are wavelength dependent, consistent with extremely fine dust, though where that dust originates and why it is arranged in such large, irregular concentrations remains unresolved. Something has been consuming or obscuring this star for longer than humanity has had the instruments to watch it. We still do not agree on what. Number 8. The impossible precision problem. The Antikythera mechanism was pulled from a Roman-era shipwreck near the Greek island of Antikythera in 1901, a corroded lump of bronze that sat in an Athens museum for decades before anyone understood what they were looking at. When researchers finally applied CT scanning technology in the Antikythera mechanism research project between 2005 and 2006, the interior of that corroded mass revealed approximately 37 interlocking bronze gears of extraordinary precision, capable of calculating the positions of the sun and moon, predicting solar and lunar eclipses, tracking the 4-year cycle of the Panhellenic Games, and modeling the movements of at least 5 planets. It dates to approximately 100 to 150 BCE. No artifact of remotely comparable mechanical complexity appears anywhere in the archaeological record for over 1,000 years after the Antikythera mechanism. This is not a minor anomaly. A device of this sophistication implies a manufacturing tradition, a body of accumulated knowledge, and a network of craftsmen who understood precision gear cutting at a level that should have left abundant evidence of its development. That developmental record simply does not exist. The mechanism appears, fully formed, and then the tradition that produced it vanishes. The Antikythera mechanism is not alone. The Nebra sky disk, discovered in Germany in 1999 and dated to approximately 1600 BCE, is a bronze disk inlaid with gold leaf depicting a cosmologically accurate star map, including the Pleiades star cluster and a lunar crescent, making it the oldest known concrete astronomical representation in human history. Göbekli Tepe in southeastern Turkey, constructed around 9600 BCE, contains massive carved pillars with astronomical alignments that archaeoastronomer Giulio Magli argued in a 2013 paper in Mediterranean Archaeology. And archaeometry were deliberately oriented toward the star Sirius and the star Deneb. Engineer Chris Dunn, in his detailed measurements of the internal granite chambers of the Great Pyramid of Giza, documented surface tolerances that he reported as approaching 0.2 inches in some locations. Precision, he argued, would be considered acceptable in a modern aerospace machining facility. Mainstream Egyptology has not replicated those specific figures, and the debate continues. But the broader pattern is difficult to dismiss. Across multiple cultures, separated by thousands of years and thousands of miles, we find knowledge and manufacturing capability that appears to exceed what the surrounding archaeological record would predict. The simplest explanation is not intervention. It is that we have systematically underestimated how much human knowledge can accumulate and how completely it can disappear, given enough time and catastrophe. Number 7. The zoo hypothesis. In 1973, radio astronomer John Ball of the MIT Haystack Observatory published a paper in the journal Icarus that proposed a resolution to one of science's most persistent puzzles, and in doing so, created a far more disturbing one. The Fermi paradox asks why, in a universe billions of years old and filled with billions of stars, we detect no evidence of other civilizations. Ball's answer was deceptively simple. We don't detect them because they don't want us to. Ball called it the zoo hypothesis. Advanced civilizations, he argued, are aware of our existence and have made a collective decision to withhold contact. Like field researchers maintaining a strict non-interference protocol with a population under study, they observe without participating. We are not overlooked. We are watched, cataloged, and deliberately left alone. The implications of this framing are worth sitting with for a moment. Every signal we have, broadcast into space, every radar pulse, every television transmission leaking outward at the speed of light, has potentially been received, logged, filed, and not answered. The strongest piece of evidence for an intentional transmission from outside our solar system remains the WOW signal detected on August 15, 1977, by astronomer Jerry Ehman at Ohio State University's Big Ear radio telescope. The signal arrived at 14 and 20 megahertz, precisely the hydrogen line frequency that scientists had theorized any spacefaring civilization would use for interstellar communication. It was 30 times stronger than the background noise. It lasted 72 seconds, the maximum duration Big Ear could observe any fixed point in the sky. Ehman circled it on the printout and wrote, "Wow," in the margin. It has never been detected again. SETI researcher Jill Tarter of the SETI Institute has argued against the zoo hypothesis on a compelling logical ground. Any system of deliberate silence, maintained across a galaxy containing potentially thousands of civilizations, would require every single participant to comply. One cheater, one civilization that decides to break the quarantine, would reveal the entire arrangement. Yet the silence holds. Tarter argues this means no one is there. But Ball's framework suggests a different reading. A silence this complete, this consistent, across this much time, is not the silence of absence. It is the silence of discipline. If they are watching, they have watched everything. Every war, every achievement, every broadcast into the void. The question is not whether contact is possible. The question is whether they have already decided we are not ready for it, and whether they are right. Number 6. Directed panspermia. In 1973, Francis Crick, co-discoverer of the double helix structure of DNA and one of the most rigorous scientific minds of the 20th century, published a paper in the journal Icarus with chemist Leslie Orgel. The paper was titled Directed Panspermia, and its central argument was as startling as anything Crick had proposed in his career. Life on Earth, he and Orgel suggested, may not have originated here. It may have been sent. Crick was not speaking metaphorically. He was responding to a genuine and still unresolved problem in biochemistry. The origin of life from non-living chemistry, the process known as abiogenesis, has never been experimentally replicated in full. The spontaneous emergence of self-replicating molecules from a primordial soup of chemicals within the time window available on early Earth faces probability obstacles that Crick found insurmountable. He expanded his argument in his 1981 book, Life Itself, making the case that the mathematical odds of life arising spontaneously on Earth were low enough to warrant considering an external source. One of his central observations concerned the genetic code. All life on Earth, without exception, uses the same 64 codons to encode the same 20 amino acids. This universality is so complete, so consistent, across every domain of life, from bacteria to blue whales, that Crick argued it was more consistent with a single external origin than with multiple independent arisings that somehow converged on identical solutions. The Murchison meteorite, which fell in Australia on September 28, 1969, provided crucial supporting context. Analysis revealed over 90 amino acids within the rock, 19 of which occur in Earth life, demonstrating conclusively that biology's molecular building blocks form in space, without biology, through ordinary chemistry. Directed panspermia extends the natural version of this idea one step further. It proposes that an ancient civilization, perhaps facing the extinction of its own star system, deliberately seeded the galaxy with the molecular precursors of life, launching microscopic payloads toward habitable worlds. Earth may have been one target among many. The meteorite ALS 84001, a chunk of Mars rock recovered in Antarctica in 1984, was announced by NASA in August 1996 to contain possible microfossils of ancient Martian bacteria, a claim that was disputed but never definitively refuted, and whose unusual structures remain without a fully agreed-upon explanation. If Crick was right, every living thing on this planet is the legacy project of a civilization that no longer exists. We are not the origin of life in this solar system. We are its continuation. Number 5. The boring billion and what it hid. Between approximately 1.8 billion and 800 million years ago, Earth's geological and biological record does something that should not be possible given the dynamism of natural systems. It flatlines. Life exists during this period, mostly single-celled organisms in shallow seas, but nothing evolves in any meaningful direction. Nothing diversifies, and the planet's chemistry settles into a stasis so prolonged and so complete that geologists named it the boring billion. Oxford University paleontologist Martin Brasier popularized the term, and a 2011 paper by Shields, Joe, and Oak in Nature Geoscience documented the chemical stability of this era in precise detail. A billion years of biological stagnation is not what evolutionary theory predicts. To appreciate how strange this is, consider the pace of evolution before and after. In the Archean and early Proterozoic eons, life transformed Earth's atmosphere, invented photosynthesis, and achieved the extraordinary transition from simple prokaryotic cells to complex eukaryotic ones. Then, for 1 billion years, almost nothing. The atmospheric oxygen content sat at approximately 1 to 4%. The deep oceans remained anoxic. Global temperatures barely fluctuated. The biosphere appeared to be locked. Then, at approximately 541 million years ago, something released the lock. The Cambrian explosion is one of the most documented and least explained events in the history of life on Earth. Within a geologically brief window of roughly 20 million years, virtually every major animal body plan that exists today appeared in the fossil record, fully formed, without obvious ancestral precursors. Charles Darwin acknowledged in On the Origin of Species that this transition was one of the most serious objections to his theory of gradual natural selection. Stephen Jay Gould described it in his 1989 book, Wonderful Life, as biology's Big Bang. The leading natural explanation involves the snowball Earth events, periods of near-total glaciation between approximately 720 and 635 million years ago, documented by geologist Paul Hoffman of Harvard University in his landmark 1998 paper in Science. The destabilization of global chemistry that followed the ice ages may have created the conditions for explosive diversification. This explanation handles the timing reasonably well. It handles the scale less convincingly. 1 billion years of nothing. Then, everything at once, in a window that, on a geological timescale, is almost instantaneous. Whatever triggered the Cambrian explosion, natural or otherwise, it did not announce itself. It simply happened, and the world it created is the one we inhabit today. Number 4. The Fine-Tuned Universe. In 1979, cosmologist Bernard Carr and astronomer Martin Rees published a paper in Nature, Volume 278, cataloging a series of numerical coincidences in the fundamental constants of physics that had been accumulating in the scientific literature for decades. The paper was titled The Anthropic Principle and the Structure of the Physical World, and its conclusions were, for two of the most rigorous scientists of their generation, remarkably stark. The universe appears to be calibrated. The fine-tuning problem is not philosophical speculation. The numbers are measured, confirmed, and not in dispute. The cosmological constant, which governs the rate of cosmic expansion, is fine-tuned to approximately 1 part in 10 to the power of 120. If it were fractionally larger, the universe would have expanded too rapidly for matter to clump into galaxies, stars, or planets. Fractionally smaller, and the universe would have recollapsed before the first star ignited. The strong nuclear force is tuned so precisely that a 2% increase would allow protons to fuse into diprotons, making stars impossible. A 5% decrease would prevent deuterium from forming, shutting down stellar fusion entirely. The ratio of electromagnetic force to gravitational force sits at approximately 10 to the power of 36. Shift it by a few orders of magnitude, and long-lived stable stars cease to exist. The most remarkable single data point in this catalog came from astronomer Fred Hoyle, who in 1953 predicted the existence of an undiscovered resonance state in the carbon-12 nucleus at approximately 7.65 million electron volts. His reasoning was straightforward. Without this specific resonance, stellar nucleosynthesis cannot produce carbon in meaningful quantities, and without carbon, complex chemistry and life are impossible. The resonance was confirmed experimentally shortly after his prediction in one of the most successful theoretical predictions in the history of nuclear physics. Hoyle was a lifelong atheist. Late in his career, he wrote that a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics. He did not find this conclusion comfortable. He found it inescapable. Philosopher Nick Bostrom of Oxford University formalized one possible explanation in his 2003 paper, Are You Living in a Computer Simulation?, published in the Philosophical Quarterly. If the constants are parameters rather than brute facts, then something set them. Whether that something is a multiverse selection mechanism, a prior intelligence, or a computational substrate operating at a level we cannot yet perceive, the fine-tuning itself demands an account that physics, in its current form, cannot provide. Fred Hoyle predicted carbon-12 from pure reasoning and was proven right. What he could not predict was what that rightness implied about who, or what, had arranged things so that carbon could exist at all. Number 3. The participatory universe. In 1983, physicist John Archibald Wheeler, a man who had worked on nuclear fission theory with Niels Bohr, taught alongside Albert Einstein at Princeton, coined the term black hole and spent 60 years at the frontier of theoretical physics, published an essay titled Law Without Law in the Princeton University Press volume Quantum Theory and Measurement. In it, he proposed something that no physicist before him had stated so plainly. The universe does not merely permit observers, it requires them. Wheeler called it the participatory anthropic principle. His argument was rooted in a version of quantum mechanics that he had spent years developing and testing, centered on what he called the delayed choice experiment. The experiment works like this. A photon is fired toward a half-silvered mirror that gives it a 50% chance of taking one of two paths. In standard quantum mechanics, if you do not measure which path the photon takes, it travels both simultaneously, as a wave. If you measure it, it takes one definite path, as a particle. Wheeler's innovation was to delay the choice of whether to measure until after the photon had already passed the mirror. The result, first confirmed experimentally by Carol Alley and colleagues at the University of Maryland in 1984, and confirmed at larger scales by Jacques Wu and colleagues in Science in 2007, was that the delayed choice retroactively determines what the photon did in the past. The measurement you make now decides the path it took then. This is not a quirk or an approximation. It is a confirmed, reproducible feature of quantum mechanics. Eugene Wigner, in his 1961 thought experiment known as Wigner's Friend, pushed the implication further. Two isolated observers in a quantum system can simultaneously hold mutually contradictory, but equally valid descriptions of the same physical reality. The act of observation does not merely record reality. At the quantum level, it participates in constructing it. Wheeler's framework implies something staggering about the relationship between consciousness and cosmos. If observation collapses quantum superpositions into definite outcomes, and if the universe's earliest quantum states required observation to become definite, then observers may be woven into the initial conditions of existence itself. A civilization sufficiently advanced to understand and manipulate quantum mechanics at a fundamental scale would not merely study the universe. It might, in a precise and non-metaphorical sense, participate in bringing specific aspects of it into being. If the universe requires observers to be real, and if the first observers capable of asking this question emerged only in the last fraction of cosmic time, then what was collapsing quantum possibilities into actuality for the preceding 13 billion years? Number 2. The Deep Time Civilization Window. In 1977, Carl Sagan published The Dragons of Eden, a Pulitzer Prize-winning exploration of the evolution of human intelligence, and included within it the cosmic calendar, a conceptual tool that compressed the entire 13.8 billion year history of the universe into a single year. On this calendar, the formation of Earth falls on September 2nd. The first multicellular life appears in mid-December. The entirety of recorded human history, every empire, every war, every scientific discovery, from the wheel to the Webb telescope, occupies the final 10 seconds of December 31st. What Sagan wanted us to feel, looking at that calendar, was the weight of everything that came before. The mathematics that underpin the cosmic calendar are not estimates. The Planck collaboration's 2020 analysis of the cosmic microwave background confirmed the universe's age at approximately 13.8 billion years. The Milky Way galaxy began forming approximately 13.6 billion years ago, nearly as old as the cosmos itself. The first population 3 stars, massive metal-free bodies that seeded the universe with heavy elements through their eventual supernovae, ignited within approximately 100 to 250 million years of the Big Bang. Their deaths distributed the carbon, oxygen, silicon, and iron required for rocky planets and biochemistry throughout the galaxy. By approximately 10 to 11 billion years ago, the conditions for Earth-like planets around second-generation stars were already in place. If life arose on one of those early worlds as quickly as it arose on Earth, within roughly 500 million years of the planet's formation, then technological civilizations could theoretically have emerged 5 to 6 billion years before our sun existed. Sagan and Cornell astronomer Frank Drake argued in their 1966 book Intelligent Life in the Universe that the galaxy had likely hosted advanced civilizations for billions of years before Earth formed. The colonization mathematics are straightforward. A civilization expanding at 1% of the speed of light could reach every star system in the Milky Way within tens of millions of years. The galaxy has been available for colonization for billions of years longer than that. The deep time window is not a fringe argument. It follows directly from confirmed cosmological measurements. The galaxy is old enough to have hosted, developed, and lost entire civilizations of incomprehensible sophistication before the atoms of our solar system had even gathered into a sun. Something should have filled this galaxy completely, a long time ago, and the fact that we perceive it as empty is the most important unanswered question in science. Whatever civilizations arose in those first 11 months of cosmic time, they have had incomparably longer to reach conclusions about existence than we have had to begin asking questions. Number 1. The universe we cannot unsee. In December 2016, Columbia University astrobiologist Caleb Scharf published an essay in Nautilus that proposed what may be the most consequential idea in the entire literature of speculative science. Not because it is ungrounded, but because it is grounded in confirmed physics, and because if it is correct, every other theory on this list is a footnote to it. Scharf proposed that sufficiently advanced life does not leave the universe. It becomes indistinguishable from it. The laws of physics themselves, the constants, the structures, the rules that govern every interaction in existence, may not be the backdrop against which civilization evolves. They may be its product. The physics supporting this possibility begins with Wheeler's delayed choice experiments and extends through a discovery made by theoretical physicist S. James Gates, Jr. of the University of Maryland. In his research into Adinkra diagrams in supersymmetric string theory, Gates found something that he described publicly as surprising. Embedded within the equations describing the fundamental structure of spacetime were error-correcting codes, mathematical structures functionally identical to the codes used to ensure error-free data transmission in computer browsers and communication systems. Error-correcting codes do not arise spontaneously from unguided processes. They are, by their mathematical definition, design structures. Their presence in the equations of fundamental physics is not explained by any current theory. Gates himself stated that he did not know what to make of it. The holographic principle, developed independently by Nobel laureate Gerard 't Hooft in 1993 and physicist Leonard Susskind in 1995, proposes that all information contained within a volume of space is encoded on its two-dimensional boundary surface, precisely as information in a three-dimensional environment is encoded on the two-dimensional surface of a holographic plate. The universe, at its deepest structural level, appears to be organized like a projection from a boundary. MIT physicist Max Tegmark argues in his 2014 book Our Mathematical Universe that the universe does not merely follow mathematical laws. It is mathematics. Its substrate is not matter or energy, but information. Assemble these pieces. A universe whose physical constants are fine-tuned to precisions that dwarf any human engineering achievement. Equations governing the fabric of spacetime that contain functional error-correcting codes. A holographic architecture in which three-dimensional reality is encoded on a two-dimensional surface. Wheeler's experimentally confirmed finding that observation retroactively determines physical outcomes. Scharf's synthesis is this: a civilization with sufficient longevity and intelligence would not build structures inside the universe. It would build structure into the universe, encoding its existence into the operating rules of physics itself, becoming, from the perspective of any later observer, simply the way things are. We have spent decades searching the sky for signals, for megastructures, for the radio transmissions of distant minds. We assumed that a million-year civilization would look like a louder, larger version of us. But the deepest possibility is that we have been reading their work every time we wrote an equation, every time we confirmed a physical constant, every time we looked through a telescope and found, with uncanny reliability, a universe that follows rules, that holds together, that permits us to exist, and to ask why. The universe is not the place where civilizations leave their mark. The universe may be the mark. If you want to see more videos like this, click the video on screen now and make sure to subscribe.